Hey guys, this is Coach Lowe, and this is Geometry for 6 isosceles and equilateral triangles. So get your notebooks out and your thinking caps on, and let's roll. All right, so here is the first set of theorems on the isosceles triangle. So 410 is the isosceles triangle theorem. If you're missing the theorems before 410, you can grab your book or talk to me in class next time I see you, and we can kind of get it lined out on what you're missing. So if two sides of a triangle are congruent, so let's go ahead and mark this one. We'll use this one for 410. If two sides of a triangle are congruent, remember when we mark sides congruent, we just put the little tick mark on there so that we know. Then the angles opposite those sides are also congruent. So let's go ahead and mark those as well. So the angle opposite this side would be this angle. And to figure out what angle is opposite, if you think about where this angle opens up, and then this side would match with it. So this angle, the opposite side is here. It doesn't touch the sides that help form that angle. So this is its opposite side. That's its opposite angle. And then for this one, it would be this angle right here. So those are our base angles on the isosceles triangle. Remember, this is the base because you know we're all about that base, All right, so these are the base angles, and they are congruent. Remember, we marked base angles congruent with a little half circle, little whoop whoop there. All right, 411, converse of the isosceles triangle theorem. If two angles of a triangle are congruent, and those would be our base angles, so let's go ahead and mark those, then the sides opposite those angles are also congruent. So it looks like exactly the same picture. On the first one, we're starting with the sides that are congruent. We know the angles are congruent. Then the converse of that is if we know the angles are congruent, then we also know that the sides are congruent. So let's look at a problem that might be dealing with that. So let's start with, we know that our base angles are congruent. So let's look at this one that I've marked with the pink or purple markings. We know our base angles are congruent, so let's put some things on these sides. Let's make this one 7, and this one 9, and this one 2x minus 15. All right, so we should be able to find the value of x off of this triangle. Because our base angles are congruent, we already know that the sides are congruent. If they're congruent, then the definition of congruent segment says that they're also equal in measure. So that means I can take 2x minus 15 and set it equal to 9. And we can solve this with a couple of steps, can't we? So we'll add 15 to both sides and then divide by 2. So adding 15 to both sides of my equation. And so that leaves me with 2x equals 24. Dividing both sides by 2, I see that x is equal to 12. All right, so when x is 12, we want to make sure that this side is 9. It's supposed to be. 2 times 12 is 24, minus 15 is 9, so that checks. So we have our isosceles triangle. All right, so let's look at one that would match this first theorem 410. We looked at one for 411, so let's look at one for 410. Let's say that this angle is 62 degrees. This angle is 4x minus 2, the other base angle. And these side lengths are both 8. All right. So we know that if the sides of an isosceles triangle, if we see two sides are congruent, that the angles opposite those two sides are also congruent, equal in measure. So that tells me I can take 62 degrees and set it equal to 4x minus 2 because this angle also has to be 62 degrees. They have to be equal. So now we can solve this and find the value of x. So 2 steps again to solve. Add 2 to both sides, so 64 equals 4x, and then dividing both sides by 4, x is 16. Or it would be 16 equals x, but we can use, what property would that be where they flip around? Yep, symmetric property. Good job. All right, so then we can plug in 16 just to make sure that this works. 4 times 16 is 64, minus 2 is 62. So we are in good shape on that. So 62 degrees for that other base angle. All right, 2 more. these are corollaries to the isosceles theorems that we just looked at, isosceles triangle theorems that we just looked at. The corollaries are for equilateral triangles. So a triangle is equilateral if and only if it's equiangular. So equiangular means all the angles are the same measure. All right, so the angles would all have to be how much? 60 degrees, yep. So if it's equiangular, then I know that it's an equilateral triangle and it works the other direction. If and only if can be abbreviated IFF. So when you see that, don't think that I've misspelled if. It just means it works both directions. So a triangle is equilateral if it's equiangular, and a triangle is equiangular if it's equilateral. So that means if all of my angles are 60 degrees, all of my sides are equal in measure, or if all of my sides are equal in measure, then all of my angles are 60 degrees. All right, then 4.4 says all of these angles are 60 degrees, which we kind of knew from the one earlier because we talked about these have to be 60 degrees to all be equal in measure because 180 divided by 3 is 60 degrees. So one follows right from the other. All right, so let's look at a couple of problems dealing with that. All right, so here, let's start with this first one. We have an equilateral triangle. It doesn't matter if I put one 60 degree or if I don't mark it at all with 60 degrees. If all the sides are marked congruent, then I know that it's an equilateral triangle. But let's just take these off, and let's say that our problem looks like this. This angle is marked 60 degrees, and this one is marked 60 degrees, which forces the third one, doesn't it? And then let's say that this side is marked as 12, and this is triangle ABC, and I want you to find the length of AB. So I know if these angles are all 60 degrees from the corollary in 4.3 that the sides all have to be the same length, which means if AC is 12, then AB is also 12 and BC is also 12. So AB is 12 units long. All right, let's try one more. If the sides are marked, let's use this one at the bottom. And let's say that my sides are marked equal to each other. And this side is 6y plus 3. This angle is 4x minus 8. And this angle is 4x minus 8. So I already know what about this triangle. I know it's an equilateral triangle. The sides are congruent. Even if I'd only marked two sides, the angle that I've put on here, the angle measures that I put on here show that these two are equal, which is going to force the third one. All right, so 8, let's make this one 8y minus 5. All right, so if I ask you to find the values for x and y, could you do it? So you can pause the video now and try that. All right, so now that we're back, let's start with y. 8y minus 5 equals 6y plus 3. Now you might say, well, wait a minute, I did x first. I solved for x first. Totally fine, not a big deal. All right, so we want to get y's on the same side. So we'll subtract 6y from both sides. So 2y minus 5 equals 3. And then we'll add 5 to both sides. So 2y equals 8, or y is 4. So we have solved for y. And when I plug 4 back in, I can check to make sure that this is correct. So 32 minus 5 is 27. And then I plug 4 in down here. 6 times 4 is 24 plus 3 is 27. So that checks, and I also know this third side, if they ask for it, it's also 27 because it's an equilateral triangle. Okay, so how would I attack these angles right here? Well, I know it's equilateral, so that makes all three angles 60 degrees. So if 4x minus 8 is equal to 60 degrees, I should be able to solve that and figure out the value of x. So 4x minus 8 equals 60. to solve this equation. It's 2 steps again. I'll add 8 to both sides. So 4x equals 68, or x is 68 divided by 4. So 4 goes into 6 one time with 2 left over, and then 4 goes into 28 7 times, so x is 17. All right, hopefully that makes sense. If you guys have questions, make sure that you ask in class, and I'll see you guys soon. This is Coach Lowe, and I'm out.